Okay, so we're talking about Isg Setup and Operation. Okay, Isg being our Internet Service Gateway. Okay, I'll just open this presentation up. Okay, so our Internet Service Gateway is our device which gives our system integration between our Wpm, which is our management system, and the internet. That comes through an online portal, which is actually hosted through Germany. So any information that's leaving the Isg is actually going via Germany and coming back to us. Means a couple of things. Means A, we can data log, so we can actually store all the information that the heat pump manager is producing, and we can actually change and look at all the information. Not quite in real time. Got about a 10 to 15 minute lag, generally speaking, but it gives us that information in almost real time. Now we have 3 platforms that we are therefore able to use. I'm going to jump in and out of this presentation a little bit, just so I can just show everybody these platforms. So what I might do, I'll jump onto platform 1. That's come up, Chris. You can see that. Okay, what we're looking at now is the customer remote platform. So the customer will get a login, they'll get a password, and this gives them remote access to their Isg, to their heating system. For those that have been in other presentations, you may remember that through our heat pump management system, we can control up to 6 heat pumps, and we can control up to 5 heating circuits. So there's only one Isg, however, per system. Now, system being up to 6 heat pumps. So we don't have to put an Isg on every time we put a new heat pump on. We only put an Isg on for the whole system as a whole. And that gives us a look over every single heat pump. That gives us a look over every single heating circuit. We can do energy metering. So this is the customer portal. So this allows them very, very basic operation. This allows them to change the operation mode. They can be at work and they can have a holiday house. They can go from standby or a domestic hot water mode, and they can put it into a comfort or back onto their program, or the other way, they can turn it off. Or they can literally be, instead of having to get up and change parameters at their wall controller, or go out to the heat pump manager to see what the status of the system is, they can actually, they can just do it from a device on the couch. Okay, it also does give them some energy information, so they can look at, they can look at the running costs and bits and pieces, and they can look at that over, as much as over the last month. Okay. So very, very basic. Some people say, for an online portal, I would like more. We've made the remote login portal very, very basic, just because there are more detailed portals you can get into if you're actually on site. But just for ease of operation, just for remote use, this is what this is used for. Okay, the next portal that people can use, well, not people, sorry, service people can use, is what we would look at being our service world, which is our back-end portal. So this is what we can see when we're logging into your Isg remotely. Okay, that's a little bit of a glitch on the screen there. I'm not sure if that's coming through to everybody. Okay, first and foremost, I might just shut some things down here. First and foremost, we can look at your data. So I'll pop onto the system data, and we'll go from the top down so everyone can get a really good impression of what it is possible for the Stiebel service team to see on your heat pump system. So we can look at all your room temperature detail. We can look at actual temperature versus set temperature. That's very important, because we can see if the actual temperature in the room is able to match what temperature the customer is setting. If it can't match, then we look at maybe we have to increase the capacity, we have to increase the water flow temperature. Potentially somebody needs to upsize a radiator in a room, but we can accurately graph that information, to give a good impression of how that system is performing. Actual temperatures, set temperatures, the actual humidity, Dew point temperature. Okay, the dew point temperature is very, very important. This happens to be the WPL25 installed in our showroom in Melbourne. Okay, now you can see down there at the moment, we've set that thing on 24 just because we want that thing to crank when it's turned on. Actual temperature 19.6, not too bad considering it's complete class Windows and it's probably only been turned on, only come on this morning. The relative humidity, 36%. So once we've got the temperature and we've got the relative humidity, we can calculate a dew point. Now the dew point temperature in this case is calculated at 4.1 degrees. Now, why we calculate the dew point is when we do surface cooling, i.e. when we want to turn that underfloor heating system into an underfloor cooling system, we want to be able to pump water at temperature through the floor that will not cause condensation on that floor. So we will do a dew point calculation and we will keep the water flow 2 degrees above that dew point calc. That way there is no chance of any condensation forming on any of the floor surface or the pipe fittings or the manifold in the distribution system leading up until up to the floor. Okay, now if we go a little bit further, we look into the actual system itself. Okay, we're looking at outside temperature, we're looking at actual temperature HK1, heating circuit 1. So we're looking at the actual temperature in the buffer tank versus at the moment the set temperature. HK2 being the mixed circuit, we're looking at the actual temperature versus the set temperature. Okay, actual flow temperature, actual buffer temperature, set buffer temperature, we can keep going. We can actually look at, on some cases, we can look at the actual heating pressure in the system if a trend module is installed. Domestic hot water, if domestic hot water was on this system, we would have the domestic hot water values as shown in this section here. It does show 2 domestic hot water tanks here. At the moment, we only have the ability to control 1. We have put this here as a future-proof measure. Cooling. Okay, we can, if we were doing cooling in this system, I do not believe we're doing cooling in this particular system, but we would actually have a cooling sensor installed. We'd be looking at that cooling sensor. This is obviously an incorrect value because there isn't a sensor there. And then we would have what our set temperature is versus what our actual temperature is. So all this information that is being shown through here is also available on the ISG. Oh, sorry, on the WPN. So you can go up onto your heat pump manager and you will actually find this same information. The ISG, however, is data logging. That is one thing that the WPM is not doing. It is not data logging all of this information. And I'll go into that a little bit further in a second. Okay. If we were driving a second heat source, we could look at that second heat source. Okay, and so on and so on. Temperature of your swimming pool, full swimming pool. So, you know, the customer can be in their, in their living room with their device, setting their schedule and so on for their swimming pool. So a lot of money can be spent on a BMS system, obviously for a high-end home. We've done a lot of the build already. And someone can just jump onto our portal and actually control their swimming pool and all their heating circuits and so on. Okay, differential controller. So if somebody was doing solar thermal, they can use a differential controller and that can all be set from their ISG. Okay, then we get into, we might just skip a couple. Actually, energy management, very, very important. When we're doing energy management, I did a little lesson on that on Monday. But obviously, what I was showing in that lesson is that we can do integration with a solar system, and that integration we can actually have a look at at how often that energy management system is being activated, and as you can see, PV output EMI status. There can be some greater integration if you're doing some high-level Modbus or KNX integration with our system. You can do some greater integration and actually see your PV outputs and energy management status. You can actually, with a SMA energy management system, it can be transmitting data to our system as well, and that can be all seen through the ISG and logged. Very important. Where that comes into great interest is, I know a lot of people are doing a lot of their sales. I know you, Chris. I mean, you're probably one of those. A lot of their sales based on the energy integration. realistically, you're probably only still touching on the surface of it, because there is some greater in-depth energy management integration. We can do back and forth data transfer and do a lot of logging, and someone can actually install the energy management application, and B, get real data as to how it's worked. Okay, heat pump. So heat pump process data. This is all the information coming through about the heat pump. So, you know, we can look at the pressures, refrigerant pressures. We can look at all these things. Now, where that gets interesting, I'm sure a lot of you have seen me show it in other presentations. We'll speed up in a second, but, you know, we can look at we can log everything. So we can log the voltage. I can log the voltage in this installation for the last 30 days. And that's quite interesting, you know, from just over 400 volts all the way up to spikes at almost over 480 volts. This is three phase, obviously. But, you know, that's the jump around of a voltage coming into our Melbourne showroom. Quite interesting. Now, if you're having problems with jobs out in the countryside and bits and pieces, this is this is where we would be looking first, to actually see the voltage, and you can actually get real historical data, and then we can look at where the faults may have occurred. We can overlay them with the voltage, and we can say, all right, we've had fault X, and we can see at exactly the same time we had a voltage spike of 483 volts. Makes for some very compelling data, and if an energy company or something needs to be taken to task, this information will be provided. So this is back end stable service portal, which is all coming through the same ISG. Obviously, the same information coming through as being shown on the WPM. Okay, I'll just jump back out of here, back into the presentation. Okay, so the main thing, just sort of showing, getting everybody across what the ISG can do. Obviously, some very significant things. One thing, sorry, I'll just get this a bit bigger. Okay. So we'll get into now the actual setup of the ISG. Okay, the setup of the ISG, I'm doing another presentation a little bit later, basically on troubleshooting and fault finding. And this will appear again because the setup of the ISG can be challenging, because it is can be technical in some instances, and we're dealing with other people's networks, and we have no control over those networks and what's been installed in somebody's house. So we're having to attach our device to somebody else's network, and that can be challenging, but 9 times out of 10, it is very straightforward. Okay, this is the ISG. That's what the ISG looks like. Okay, you'll note we have just a power. So the ISG needs to get powered from a transformer, which a little power plug transformer that we supply. So normally the ISG would be mounted next to the WPM, excuse me, and there would be a double power point, and the WPM and the ISG can just get plugged into that. You can't wire the ISG from a power point of view from the WPM, because it has to have its transformer. Okay. Then we've got the CAN bus. The CAN bus is a cable we also supply, this cable here, and it's the cable that connects our ISG into our WPM. For those who haven't been in other presentations, WPM is our heat pump management system. So we provide the cable from the ISG to the WPM. Now that cable comes at a certain length. I think that length is about 5 meters. We really don't like to see that cable being extended. So we would prefer the Ethernet being extended to the ISG, then the CAN bus from the ISG to the WPM be extended. Okay. It's just purely for data transfer reasons. We just want a nice, clean, reliable signal without dropouts. As you can imagine, ISG dropouts or something could be the cause for a service call, and that can be painful. So we would just want to reduce that problem by making the installation as compliant with our guidelines as possible. Okay, so there's the CAN bus cable. This cable here is just the Ethernet plug-in. So it says it there, Ethernet. We do provide a patch cord, so normally speaking, the WPM is installed in the plant area near the heat pump manager, and a double power point is installed there, and an Ethernet port is installed there next to where the ISG is going to be. And the patch cord that we provide plugs from the ISG into the Ethernet. Now, you'll see a light, an LED over here, which is on the right-hand side, which is the power indicator. So when that's green, means the power's on. And you'll see two LED indicators over on the left-hand side, X1 and X2. X1 shows the status of communication between the ISG and the WPM. So while ever X1 is flashing green, you have communication going back and forth between the ISG and the WPM. The X2 is the indicator between the ISG and the network. So when the ISG is powered up and the Ethernet is plugged in, after a couple of minutes of a boot up, the X1 and X2 will start flashing, and then they should then, after a couple of minutes, the indicator, they should steady onto what their indicator is trying to show you. X1 flashing, obviously green, mean communicating the WPM. X2, if it goes solid red, it means it's found the network. Now we have to get the ISG set up. So on initial installation, you will plug everything in, wire it into the WPM, power everything up. You should see a flashing green light, and you should see a steady red light once it's all booted up and found everything. Okay? Sorry, I'll just make one more point. The Ethernet port also has a little LED indicating that it is plugged in and connected to the internet. Okay? Now, if you plug that in and no LED is indicated at the Ethernet port, it's only a tiny little LED on the corner. If you plug that in and there's no LED showing there, you have no connection to your internet. And then you may talk to the WPM, but you will not find the network. Okay, so all the indicators are on the ISG. It's just obviously learning what those LEDs are trying to tell us. Okay, so this is the WPM wiring. For those that have been in other presentations, you'll note that all of your sensors and your communication wiring is in the top, and all the power and all the pump sets and everything go into the bottom. Now, the bus network, we communicate via Modbus. So the bus network, or the bus terminals, you'll see are the top, these two, the top left, the red and the green, and the top right, the red and the green. Now the red bus so the red bus network, the communication wiring, go to the heat pump, and the green are for all the accessories, the ISG being an accessory. Okay, so the ISG wires up into the green bus ports. Can be either green bus port, does not matter, because that green and the other green in X118 are exactly the same. So what we'll do is wire into either one, as I said. I'll show you the wiring configuration in a moment. If you happen to wire the ISG into the red bus, in fact, you can set the whole thing up. The lights will all appear okay, but the data transfer will be incorrect. So you can wire it into the wrong bus, and you might walk away thinking everything is okay. But in fact, when we go on to actually see what data is coming down the ISG, we'll say, all right, okay, we actually don't have any data transfer. We have a connection to the WPM, but we don't have any data transfer. And I've, on a number of occasions, said, let me take a photo. Where have you wired your bus wiring into? It's into the red instead of the green. Okay, so be aware, ISG is an accessory. Accessories wire into the green bus network. Okay, ISG. So here is just a slide, and I'm showing this is the wiring combination that wires into the green bus. Okay, we supply the cable, as I was saying, we supply the cable between the ISG and the WPM. The cable will have three colored wires come off the end: white, your brown and black, and the high, low, and earth. Okay, now to save confusion, H is high, L is low, and your minus is in fact your earth. Okay, we've possibly made that a little bit confusing. Earth, ground, and minus are in fact the same thing. Okay, and that is showing what I was just showing there. That is showing that LED status. So we've got X1, it'll give you what I've just explained, and we've got X2, it'll also give you what is explained. Note, once we've got the ISG set up and we hit the accept button, the X2 will go green. So ultimately, a customer will be able to look at their ISG, all green lights, and all green lights mean all go. So all green lights is good. If there is anything flashing red on your ISG, there is a problem of sorts. Okay. Now, when I mean set up, we'll go into that in a moment and actually show you how to set up your ISG, because until we do a privacy law acceptance and a customer information setup, that will remain red. Once all that data is entered, then that we'll put an acceptance on that, and that data will show green. That X2 will show green. Okay, now how do I set up my ISG? Now, I've done a little bit of a presentation into how to do that, but also I'm going through some data. Stefan has made an absolutely beautiful step-by-step PDF on how to do that. So I'll just do a little quick show how to do it. Then I might take you through Stefan's PDF, because it is well laid out. And in fact, that's what we will be sending out to everybody. So you'll have your own step-by-step how to set up my ISG. Okay, firstly, you have to plug in the ISG and you have to check the LED lights. Okay, when the LED light on X2 stops blinking and it goes solid red, we should, therefore, that ISG should be connected to the network. What we do, we have to go into our folders or documents folder, which is down the bottom. And I'm talking obviously a Windows computer at the moment. We'll get into how to do it on Macs in a second. But in a Windows system, the easiest way is to go down and open the documents. Then you, over on the left-hand side, you will see all the menu options, and you go right down to the bottom to network. Double clicking on network will open up your network search screen, and you will therefore do a search on all devices on the network. One thing I didn't mention, your computer has to be locally on the same network as the ISG. So you need to have this can be done on the customer computer. This can be done on if your installer, if you have a laptop, take it to site, get onto the customer network, and you will be able to do a network search on the same network and find the ISG. Now, when you open up network, the ISG will be clearly identified as Internet Service Gateway. It should just be there. You will double click on that icon, and then you will bring up the local area network page. So once you double click on the Internet Service Gateway, this screen will come up. Now you'll note this screen looks a lot like the customer portal, which is the remote portal. And it basically is the same platform. Difference being, this gives a whole lot more detail. So this is, in fact, what the customer can use as their at-home portal for their unit. The reason they'd use this one is because it gives them all their programs, the programs being all their schedules. So they can set up their schedules. They can change all their room temps. Obviously, your domestic hot water, everything that's attached to the system will come up. If it's got a combi ventilation unit, in fact, it'll show all that too. It'll show your portal status. So what your connection is, it'll show any fault status for the customer. Obviously, all your energy usage data, the customer can have a look at that. There may be cases you don't want the customer to see this, and that's fine. You do not have to give them this information. It can purely be used as a service tool for Stevel. And obviously they can change their operating mode. Now, in the settings in this customer portal, to do any high level settings, as in change, domestic hot water modes and change sensitive operating configuration, they will have to have an access code, which, you know, they will, generally speaking, not have. Okay, so this portal is being used for the customer to use as their day-to-day scheduling, turn things up and down, and it is used for the installer to set up, you know, all their bits and pieces if they don't want to use the WPM. Okay, so once the customer is on this page, they will push establish connection. Okay, click on that establish connection icon, and then sorry, I'll just jump out of this and just pop on another screen quickly. Bear with me, sorry. Where are you? Sorry, just ISG commissioning. Okay, 1 second. I'm just bringing up the ISG commissioning. Sorry. Don't forget, just pop down any questions that you may have, because I do want to spend a little bit of time at the end, just going through. Here we go. Sorry, everybody. Okay, so is that showing ISG commissioning steps? Sorry, are you there, Chris? Okay. Okay, so this is the PDF that Stefan has made, beautiful little PDF with the ISG commissioning steps. Okay, I just want to pop down to one important, I think. Okay, so when established connection is pushed, you will come up on your screen with welcome to the new service well. Okay, then you will have to accept a data privacy condition page. Then this is where the customer will put in all their information. So, you know, the customer details, you know, street name, house number, so on and so on. It is important to get all this information in the correct spot. Now, this is actually, as Stefan shown how to, is actually filled in, as in street and house number. You will put your street in, you will put your house number, you put your town, you put your postcode. If it's not done in this format, the system will ask you to re-input all that information. Now, unfortunately, reading through this, you'll note that Australia in the country section does not allow, has not given us, oh, sorry, the Germans have not given us our own country as far as on the ISG yet. So for country, we just put -- instead of Australia. Once that is all done and you hit accept, you will have the option, it'll say data accepted, and the system, you'll go back to the front page, and the front page will ask you for a portal key. That will be back in the portal status place. You click on enter portal key, and Stiebel will have to give you a portal key. So we'll generate you a portal key. So you need to get in touch with Stiebel, with our service department, and we will give you a portal key. Now, your portal key will arrive on the email address that you have provided. If you need it urgently, however, do contact us at Stiebel in the service department, and we will be able to give you that straight away. Once that portal key has been entered, it is case sensitive. Then it'll say status accepted, and you will have data transfer. Okay, so that is how to connect up the ISG. This PDF is available. You know, it has been, I find once I have given people this PDF, they are able to follow it through on a step-by-step. And in fact, most people are able to set up their own ISG just based off this. Once somebody's done it a number of times, generally speaking, they can do it quite easily themselves anyway. There are a lot more, probably more in-depth technical, as in assigning a particular IP address. There are all these interesting things you can do if you're a little bit more tech savvy and you want to go a little bit further into the setup, or you're getting an IT person involved. There are obviously a lot of installations. Some installations are commercial. Some commercial IT installations are quite sophisticated. So we can, we can go further into and, assigning obviously IP addresses and servers and all sorts of things. So I'm more talking just from a standard residential installation. The step-by-step, generally speaking, is fairly straightforward. I'll just jump back onto my presentation. I did mention Mac. A lot of people use a Mac to set up the ISG. If you're using a Mac and you obviously cannot just do a standard network search because it doesn't come standard with a Mac, you'll have to download an app as an IP scanner. Now, on my computer, which is Windows-based, I've got an IP scanner as well. Sometimes I just pop on and do an IP scan. So if you're an installer or a technician and you're involved with a lot of these, an IP scanner, they are specifically made for that task. So to get a current good IP scanner, be it a Mac or be it a Windows computer, is not a bad idea. It can just save issues. If you are doing an IP scan or a network search and the ISG is not showing up on that network, I would always be looking at the LED status on the ISG itself, and I'd be looking at why. I'd be looking at what is not flashing and what potentially is happening. Particularly look at the LEDs at the actual Ethernet plug, okay? Now, interesting one. You do not need to be hooked up to the Wpm, which is the heat pump manager, to register an ISG. So ISGs can be registered from if you're an installer, can be registered from your office, or ISGs can be registered from the Steve Beltron office in Melbourne, and in some cases can be sent directly to the customer. So, we've had cases where we've had an ISG, the customer or the installer just could not get it right, could not install it. And we've said, righto, let's just, to save any more problems, we'll register the ISG, give us the information, we'll register it, and we will send it straight to your customer. Now, obviously, the wiring has to be done correct. So, that's something that needs to always be checked, the wiring between the ISG and the WPM, because otherwise we won't get the information anyway. We could be online, but we won't have the information. Okay, so I was just showing, so portal status, click on portal key, available once you've put all your information in, and then it'll be accepted. Okay, this just shows you the mobile friendly version of what the ISG can show to the end user through the service world. So, some pretty good information there, if you want to set up a customer with all that sort of stuff. And once again, this is the back end stuff. Okay, what I'll do now is I'll jump out of this. That's 36 minutes in. So we've got probably another good sort of 10 minutes. We will open it up. If anyone, I'll just have a look at the chat bar here. Has anyone got any questions? Just 1 second. I'll just stop my screen sharing. Okie dokie. I might even just give you guys a look at me. Okay. Is anyone? I hope that was helpful. Like I've mentioned, the PDF is available. An easy step to do PDF is available. We're always here to help. Things to remember, if I have to recap, things to remember, check your LEDs. Okay, LEDs are the giveaway. Do an IP scan, be it with an IP scanning app, or be it if you've got a Windows computer, just through the standard network search that's available in your documents folder. Set it up in the office. Okay, so people like like the Energy guys I can see, set it up in the office. If you're not sure about the customer network or so on, you can set up the ISG. You can put all the customer detail. When you take it to site, all you got to do is plug it in, and it'll automatically configure, find the network. Nothing has to be activated on site. So it is a good tip to, and I can some Steeple guys here. It is a good tip to be encouraging people to get them set up online. Okay, Rani's just saying, hang on, I might unmute you, Rani. You might just explain that to everyone. He's find some unmute you, Rani. Just want to explain that, Rani, if you wouldn't mind.
Yeah, sure. I just wanted to maybe offer a little bit of options there, because you can get these IP scanners and some of them are very simple. You don't have to install them. You can just carry them on a stick. They take basically no memory really, and so you can just put them wherever you are, just run the scan, and it will check everything that's connected to that network. As long, obviously, as you're connected to the same network, it'll list pretty much every IP that's there. This one that I'm saying is one that I use. It's very, very simple to use, and it's free. So I just thought I'd provide some stuff there. Yeah.
Thanks, Ronnie. Good on you, mate. Okay, just another question. Just when we're talking fault finding. So what I might do, I might turn my video back off. I'll just screen share again, guys, and we'll just jump back on to the back end. Okay. So if we just go back, we just go back a screen. The question has been asked. What standard screens would I go through fault finding? Okay. Standard screens. I'm going to do a bit of a troubleshooting. Probably in the next couple of sessions as well, Michael. Hope you can jump in. But if you can't, what I would normally be looking at. Okay, I'd be looking at buffer temperatures. So I would be coming down. I'd be going into the. I'd be looking at actual temperature of the buffer, and we can see it's up and down, up and down, and up and down. Now, normally, if a buffer temp is heading up at such an angle like that, it's because the heat pump is making more energy than the heating system is distributing. So sometimes then what we do is we make the heat pump less. We turn the heating curve down, or we make the heat pump less aggressive. And these are the things. So we'd like to flatten that curve out. So the heat pump's just running, just trickling in what temperature is actually being lost by the distribution system. So things like buffer temperature. Now, what I can do is I can overlay a data point. Okay. Now, so generally speaking, we've got, this takes a little bit of figuring out and getting used to. Sometimes you just got to jump in and just start playing with it. But what I'm looking at now is how to add another overlay to that graph. So what I would go into, normally speaking, is the heat pump. And in heat pump, we would look at process data, because process data is in fact the, we're looking at the compressor speed, all those things. So actual compressor speed, let's have a look what this heat pump's doing. It's just basically going boom, because we've probably got the thing set. This is just a showroom one. So we just got it, running in a fairly crude manner. So as you can see, when it's starting up going straight to 50 Hertz. We can give our heat pumps, which I'll go into more on the advanced commissioning, we can give the heat pump a target to hit when it started. So instead of it starting at very, very low and ramping it all the way up from the bottom, we can say, we know our heating system is this big, start at that. And then it can work its way from there. So a lot of the time I'm looking at actual temperature of the buffer tank, what the compressor is doing, but another very, very important one, just to answer your question, is water flow rate. I'm doing a troubleshooting one soon. Am I doing that? The next couple of sessions, I'm going a bit more in depth into troubleshooting and repair and bits and pieces. But water flow rate is 100% one of the biggest issues that we have, either pumps are undersized, not even that wouldn't be one of the biggest issues, but the biggest issue we have is air in the system in commissioning. That is the biggest issue we have. And I get on almost a daily basis contractors arguing with me, telling me I'm wrong, that the pump is running and there's flow, and I just very confidently and calmly tell them that they're wrong, that we can see the water flow rate. There is no water flow rate, therefore they have no flow between their heat pump and their buffer tank. In this case, you can see we're getting over 37 liters per minute. It is jumping around a smidgy bit, but not a lot, between 32 and 37 liters per minute. The nominal flow rate on a WPL 25 is in fact, about 24 liters per minute. So we are well exceeding what the nominal flow rate. The minimum flow rate is 15. Okay, so I'm always looking at this, Michael, what the flow rate is, and I probably don't want to jump into actual customers' ones and show you real data on ones that I've been playing with, but one I was playing with last week, I could clearly see. So I could look at the flow rate, and you want to see, if we want to show you something pretty cool, I can look at the flow rate. I can go into say system. Actually, we'll just go back into, info. We can go info, system. What do I want to look at here? I want to go into diagnosis, and I can go system status. Let's look at the WPM. System status. And we can look, actually go into each individual pump. You got to find it sometimes. Look at your operating mode. You can go into each individual pump, and you can have a look at what is actually running. So we can look at the water flow rate of the heat pump, or a particular heat pump. Don't forget, we could have multiple heat pumps on this one installation. So we could look at the water flow rate going through that particular heat pump, and we could look at if that pump is actually going. So we could have an application where the water flow rate is 0, but we can say, all right, but we can see the WPM is telling the pump to be running. So quite often I do that. Quite often I'm looking at that type of thing. There's the other typical things I'm looking at in the ISG. In very important ones I'm always looking at, let's go down to the bottom here, amount of heat and power consumption. Now we can look at the amount of heat per day, the power consumption per day, and we can say, all right, I can look at, I know on that day it used 36.5 kilowatt hours, on that day is 43. And we can look at the power consumption. We can look at it between a time period if we so wish, or we can just say, let's look at the last 30 days. More and more and more. I mean, it might have been getting colder in Melbourne. I'm not exactly sure why it's going up. I mean, that's not from 0 to 43. Obviously, that's starting at 25 there. But on that, we can overlay the heat output over the power consumption. And then we can, for every single day, look at what the consumption was versus what the heat output was. So and then we can overlay, if we want, the ambient temperature. So we can look at the COP basically from that calculation. We can calculate the COP for any particular day, average COP for any particular day, and see what the ambient sensor was doing at that time. Another interesting thing, I've had units which have been installed with very, very poor airflow. And I've been able to have a look at what the outdoor ambient temperature sensor is telling me versus what the outside temperature as measured on the back of the unit. And I can see if it's recirculating, I can see there's a difference of 5-6 degrees, and we can give customer, I mean, we wouldn't, we give the installer, but we can give somebody a good indication is the low, what's the efficiency loss because I've installed this thing with grills across the front of it, like with in an enclosure instead of in fresh air. We can say, right, well, you're dropping 5 degrees of ambient operating temperature on average for that unit. And a 5-degree ambient difference on a WPL 25 might be a COP of 0.5 or 0.6 or something. We can measure that stuff. We can look at every single heating circuit and see what the temperature set in that circuit is versus what the heat going to that circuit is. Chris, think a recent job, heating circuits. What I did was I looked at what the set point for a particular heating circuit was, and I looked at what the actual temperature as being measured, water flow temperature as being measured on the sensor going to that section is. And I could see it was all over the place. I'm saying the set point in the room saying stop, but I'm still getting temperature, calling for temperature on the heating circuit. It's not right. I knew something wasn't right. So takes a bit of playing with, but you can in fact, one thing I didn't mention, you can in fact go in and look at all the parameters. So I can have a look, I can set the time if I want, but I can have a look at every single parameter in that system, heating circuit 1, and I can go and I can set the temperature, turn temperature up, temperature down, heat curve rise 1.5, heat curve rise on underfloor. This is in the Melbourne showroom underfloor. 1.5 heat curve is massively high. We've obviously done this because of, it's a big open area with massive glass, so therefore it's incredibly inefficient. We've put a high heat curve there because, walking in there, the main thing is seeing a warm floor and seeing the thing operating. So they want to be able to turn that unit on and have it operate so people can see it going, punched a high heat curve and a high comfort temperature. But normally, underfloor heating, very well built house, 0.6 to 0.8, and radiators or something, maybe 1.8 to 2. Cool. All right. What I'm going to have to do, I'm going in another session in about 10 minutes. The next session is on repairing. So we're actually talking repairing WPL. I'll go into some componentry of the WPL and repairing the WPM. I'll take you through some bits and pieces, but I'm not sure if there's any other. What do you got there? There's one more question. I might just jump on. Oh yes, you found it. Okay, yes. So the pop-up screen, so you can select extra data point. That's the thing you were missing. Okay, so yep, you can keep laying over pop-up screens and picking different times, and then you can be on the screen and you can actually zoom in to particular areas. There's a lot of detail and a lot of data we can get. You can spend a lot of time sitting looking at the ISG. There's obviously some pretty serious converts we've got over because of this data we can provide, and they can be looking at it. You've got remote installations. You're doing a chalet up in the snow or something like that, and you can have 6 heat pumps. Don't forget, the ISG actually does go onto our WPI range, which is our new our large ground source. So we can have 16 WPIs cascaded together onto one system. 16 of those could be, and they're 87 kilowatts each at Ryan 0. So, realistically, we can get the best part of 100 kilowatts in a lot of installations out of each. 1.6 megawatts. You can do some serious sized installations with these systems, serious sized installations, and have it all come through the ISG. So from a commercial application, like probably Michael, what it gives you for a site is second to none. It's invaluable information. You can go through every heat pump individually and have a look. We've had heat pumps which have had low flow rates on that particular heat pump, and you can tell, and you can see the COP on that heat pump. Yeah, that's a good one, Chris. Can we get some typical actual performance data? Look, I'm sure we can. I'm sure we can. And you know, the more units we get on the ISG, the more real world climatic data we can get, and real world, data. It's changing the way we're setting up units. This is the reality. We've had units where I've gone and done a commissioning. I did a retrofit in Canberra. I know I'm out of time, but I did a recent retrofit in Canberra. You make an assumption that the heat curve should be this, and over the course of about 3 weeks, I turned the heat curve, because it was on older radiators, but I turned the heat curve from 1.8 down to about 1.4, maybe even lower, because the building performed a lot better than expected. And when the building was performing better than expected, we turned the heat curve down, and over the course of 4 weeks, we got the average COP from in the low 3s to over 4. So, we've given that customer 30% more on actual efficiency by just looking at the data. Now, someone's got to actually sit and look at that, but that in my mind was a massive victory, and we're doing a nice case study over that, and but yeah, it's a good one, because I've got 7 minutes. I've got to start another one, so I might just jump out so I can get myself organised. But thank you very much, everyone, for attending. May see you in the next one. Cheers.
Thanks.